All right, so this is lecture 13, and in this lecture, I'm going to divide it up into two videos because I'm going to start by just reviewing this concept of statistical inference and null hypothesis testing that we covered in lecture 12. So I'll have this kind of review section and then a bunch of practice, and that will be one video. And then I'll start another video, still lecture 13, in which I'll introduce two types of tests for categorical dependent variables. Okay, so we'll start with this review. So let's just go back and say, like, what's the whole point of what we're doing here again when we're doing null hypothesis testing? So the point is that you've completed a study or experiment and you've got the data in hand. For example, maybe you're studying the relationship between heart disease and smoking, and maybe you obtain some data like this, where each data point on the scatter plot is a person in your study, and you've measured their heart disease, you've measured how much they smoke, and you want to know, do people who smoke more have more severe heart disease? These data are made up, of course, although there's lots of real data out there on this association. Okay, so you know that all studies are subject to random chance, sampling error. And so it is possible that you could get data like what's shown in this scatter plot just by random chance. It's possible that smoking could have nothing to do with heart disease and you could observe something like this. But you've got this data and you want to figure out what's the probability of getting something like this if there was no real association. So the whole point is we've got our data and we want to know, is the result here real? Does the data justify a particular conclusion given that there's always going to be some probabilistic influence on the kind of data values we get? Okay, so just some definitions again. Remember, our main hypothesis or our research hypothesis, two kind of terms that mean the same thing, that's the explanation we're interested in. That's the thing we want to test. And it might be something like, there is a relationship between smoking and heart disease. Or it might be something like the chance of getting polio differs for this vaccine as compared to a placebo. Our null hypothesis is a negation of our main hypothesis. It's a negative statement. It's the possibility that there's no effect or no relationship or no difference. Okay, and so what's the p-value doing again? Well, you can think of the p-value as telling you how surprising would it be to get the data you did if there was no true relationship or no true effect. In other words, if there was nothing going on, if the null hypothesis was true, how surprising would it be? How probable would it be to get this particular data set? So how likely would it be that we see a result like this if smoking was not related to heart disease? So P is a probability, and it is the probability given the assumption that the null is true. And because it's a probability, it can take values that range from 0 to 1. If P is really small, that means that we would be unlikely to see the data that we got if the null was true. And what we do in that case is we reject the null hypothesis. If P is fairly large, we fail to reject the null. And by convention in biology, the most common place to draw that line is a p-value of 0.05. So the most common alpha threshold is 0.05. But it's not the only alpha threshold you could have. Okay, so here are some examples of correct ways to word conclusions. And this is not an exhaustive list. There are more ways you could word your conclusions, but I'm just trying to kind of show you the pattern here, right? So if your p-value is small on the left, if your p is less than alpha, you might describe your result as being like, the result is statistically significant, or there is a statistically significant association between the variables, or there is a statistically significant difference between the groups, or the treatment had a statistically significant effect. Alternatively, if your p-value is greater than alpha, so you're over on the right-hand side of this slide, you would word your conclusions as something like, the result is not statistically significant. There is no statistically significant association between the variables. There is no statistically significant difference between the groups. There was no statistically significant effect of the treatment. Or we did not detect an effect of a treatment. We did not detect a difference between the groups. We did not detect an association, and so on. So why can't we accept the null if we get a really large p-value? Well, remember, the p-value is the probability of getting the data you got, assuming the null is true. We can't use the p-value to prove the null because the process of calculating the p-value assumes that the null is true in the first place. Another way to think of it is that we can't prove a negative. We can't prove that there's no effect. Because even if we get a really large p-value, there still could be some effect of the vaccine or some difference or some association, but it could just be a very, very small effect that we didn't happen to detect in our data. So we don't accept the null. So again, students often ask, like, how can I learn this stuff? And the key is repetition and lots of practice applying it in different scenarios. And even the most experienced researchers easily forget what the p-value really means. And that's because it's such a weird, convoluted, twisted logic that goes into it. It's not something that is easily intuitive. And so it takes a lot of repetition and practice to really internalize what it means. I really like this meme because it correctly presents it. So I think these memes can be really good study aids. I want to also point out that we're learning null hypothesis testing because it is by far the most common framework for statistical inference used today and used over the past century. And so you need it to understand the scientific literature, and you'll need it in your future courses in biology. However, it's not the only way. And so I want to take this moment to mention that if you go on in data science, if you go on in statistics, there are other frameworks for making inference. One example is Bayesian statistics. And if you're interested in this course, I would really recommend going on to more advanced courses and learning Bayesian statistics in the future. Okay, so at this point in the video, I'll present a bunch of practice questions covering kind of fundamental concepts of statistical inference and applying the null hypothesis testing framework. And we'll take up the answers to these questions in our Thursday Zoom meeting. And then after these practice questions, I'll pause, and then there'll be another video associated with this lecture. Okay, so first of all, for A, B, C, and D here, can you identify which ones are null hypotheses and which ones are main research hypotheses? And okay, another question of the same type for A, B, C, and D. Identify which ones are null hypotheses, which ones are main hypotheses. Write down your answers. We'll take this up on Zoom. Okay, here's another practice question. Suppose that a clinical trial was carried out to test whether a new treatment had an effect on people's ability to recover from a knee injury. And the null hypothesis is this new treatment has no effect. And suppose the study rejected the null hypothesis with a p-value of 0.04. Now, for each of A, B, and C, I want you to state whether the A, B, and C are correct. So it's kind of like, is this a correct application or incorrect for each of A, B, and C? Okay, so the next couple of slides have examples of quotes from out in the world about null hypothesis testing. And so this one has to do with a newspaper report looking at a scientific study on the sex ratio of children born to families in Northern Ontario. And that study found that Northern Ontario, the sex ratio at birth significantly deviated from the North American average. And so the newspaper article claimed that there was only a 1% probability that the results were due to chance. So what do you think that statement, that quote, refers to? What a concept out of what we've learned is that sentence about? And the sentence has an error. Can you rewrite the sentence so that it's expressed correctly? It kind of correctly applies what we've learned. Okay, same idea here. This one comes from an online math textbook. So in this Math World website, it had this hypothesis testing webpage that said, hypothesis testing is the use of statistics to determine the probability that a given hypothesis is true. And so the question is that correct? And if it's not quite correct, can you clarify it to make it correct, given what we've learned so far? All right, so this one is another example of correct versus incorrect. So for each of A, B, and C, read the sentence. It presents kind of an imaginary scenario of a research study and a statistical result. So read the sentence and identify whether it's reported correctly. And if it's not reported correctly, which part is incorrect and how would you fix it? So do that for each of these three and we'll take it up on Zoom. Okay, so in this scenario, a research team is testing whether vitamin C can prevent colds. They give 10 people in their experiment a daily vitamin C pill, and another 10 people in the control group get a daily placebo sugar pill. The researchers survey the subjects to see if they get a cold over the subsequent days, and what they find is that 3 out of 10 people in the vitamin C group got a cold, whereas 5 out of the 10 people in the control group got a cold. And they report a p-value of 0.65 for the comparison of the probability of getting a cold in these two groups. And they conclude that there's no difference between the two groups, and therefore the vitamin pills have no effect on colds. All right, so is that the correct interpretation of that test result? And if not, what would you conclude instead? Okay, so that concludes our practice questions. And I just want to remind you that non-significant results do not mean no effect. If you make this mistake, you're in good company. It's a really, really common mistake to make. This data visualization shows the result of a meta-analysis of 791 articles across 5 journals in the sciences. And the researchers read all of these articles and they scan them to look for cases where the authors made this mistake of saying that because the result was not statistically significant, what they said was there's no effect or no difference. And they found that that mistake was made in about half of the articles. So many practicing researchers lose sight of what null hypothesis testing is really doing. And so that's why we're spending so much time to practice these core principles. All right, so I'm going to stop this video and you can continue on lecture 13. It'll continue on in the subsequent video here.